Okay, here's another combination circuit. This one's more complicated than the last one. Just more resistors, really asking pretty well the same thing. First thing we got to find is the total resistance. So I can see that I've got three parallel here and two parallels there. So I'm going to find this parallel first. So 1 over R is 1 over 12 plus 1 over 6 plus 1 over 4. So that ends up being equal to 2 ohms. And I'll do this one next. 1 over R is 1 over 5 plus 1 over 20. So that R is going to be equal to 4 ohms. Okay, so now I've got this one and this one. I can replace these two when I redraw it. There's 1, 2, 3, 4, 5 cells here. You know what, I'm not going to redraw 5. I'm just going to redraw 1 because I'm lazy. But you come down, come this way. This one has been replaced with 2 ohm. That one is still 22 ohms. And you go down, this one is still 8 ohms, and this one is now 4 ohms. So 2, 22, 8, and 4. And this is 27 volts. I'm going to figure out what these are both, these two are in series and those two are in series. So for this one, it's going to be 2 plus 22. So that resistance is 24 ohms. And this one is 8 plus 4. So that's going to be 8 plus 4, 12 ohms. So I'm going to redraw that. So that one is 24. This one is 12. So 27 volts, 24 ohms, 12 ohms. There. Now, finally, I have one last one in parallel. So that's going to be 1 over R is 1 over 24 plus 1 over 12. So that resistor is going to end up being 8 ohms. So I'm going to redraw that. There you go. That answers part A. 8 ohms. Okay, so now I have my total resistance.
Mr. McNeil, contact the office, Mr. McNeil.
Yeah, Mr. McNeil, contact the office. All right, where was I? Let's see. Oh, yes, okay. 27 volts is my total voltage, and 8 ohms is my total resistance. So if I go I equals V over R, I can go 27 divided by 8. 27 divided by 8. What's that going to be? 27 divided by 8. 3.375, which I'm going to call 3.4 amps. Let's see. I'm not even sure if that's one of the things we're supposed to find. We're supposed to find I1, I2, and I3. Well, let's see here. I1 is here, I2 is there, and I3 is there. So what are we saying here? All right, I1, I2, and I3. I1, I2, oh, and that's what we're trying to find. I found this I, so I'm going to ended up, let's see here. I'm going to end up putting my values in, and I'm just going to find them after. I don't really care about I1 and I2 and I3 right now. I'm going to do it in red. 3.4 amps is there. I'm going to back up to here, and I know right away I can't, there's nothing I can do about this one because it splits off into parallel right here. I know this is 27, so I will be able to find, because these are in parallel, that's 27 volts, that's 27 volts. I can figure out what my current is in those two by going I equals V over R. So V over R, that's going to be 27 divided by 24. That's 1.125. I'm going to call it 1.13. And 27 divided by 12 is 2.25. And when you add those two up, they end up being pretty close to 3.4. So perfect. So there's my two currents. I can travel over to here now. This is in series, so this is 1.13 amps, that's also 1.13 amps. And for this one, 2.25 amps, 2.25 amps. Now, when I back up to this circuit, some of these things will be in the right spot. So for instance, the 22 ohms, that's still 1.13 amps. And my 8 is still 2.25 amps. All the other stuff, I can't tell what current is there. I just know that this one adds up to 1.13 and that this one adds up to 2.25. But what I can do is I can go back to my Ohm's law formula, V equals IR, and I can figure out what my voltage is in all four of these. So it's just going to be I times R. So 1.13 times 2, that's 2.26 volts. 1.13 times 22 is 24.86, so I'm going to call it 24.9 volts. 2.25 times 8, that's 18. And 4 times 2.25 is 9. Okay, so when I take these, I can travel backwards to where I need them. This one I know is 18 volts because it says, and this one I know is 24.9 volts because it says. These two are in parallel, so 9 volts and 9 volts. And these three are in parallel, so 2.26 volts, 2.26 volts, 2.26 volts. You can just see how complicated this is getting. It's just getting messy. What I want to do now is I want to find the current for the ones that are missing. Current is V over R, so I'm going to find V over R for these two and those three. So V over R, 9 divided by 5. That's 1.8 amps. And 9 divided by 20 is 0.45 amps. When I add these two things up, they should equal 2.25. I'm just going to check. 0.45 plus 1.8, 2.25. Good. So I'm going to go back to my V over R for this. So 2.26 divided by 12. That's 0.18. 188. So I'm going to call it 0.19 of an amp. 2.26 divided by 60. That is 0.0376. So I'm going to call it 0.038 amps. And 2.26 divided by, what's that, 40 or 4? Well, that's 4. So that means that last one's wrong too. This is 0.57 amps. This one's wrong because I thought that was a 60, but it's a 6. 2.26 divided by 6. 0.377. So I'm going to call it 0.38 of an amp. There. That's totally messed up, but you should be able to see everything when you got different colors. Now I can go back to the original question and figure out what the heck it was asking. Let's see here. It would like to know what is the current at I1. So at its beginning point, what is the total amount of current that's coming out? I go down to the bottom here, and I know that that is 3.4 amps. So I1, 3.4 amps. It also wants to know what I2 is. I2 is what's going down this middle bit of circuit. I go back to here, my middle bit, 1.13, 1.13. So I2, 1.13 of an amp. And I3, which is my bottom, which is the bottom, I3, 2.25 of an amp. So there you go. Those are the three currents. For part C, it wants to know the voltage in the 12 ohm resistor. Well, which one is the 12 ohm resistor? Well, that's this one right here. So voltage in the 12 ohm resistor is 2.26 volts. So we got that. And the power dissipated.
Mr. Shoreful, telephone line 1.
The power dissipated in the 8 ohm resistor, that's this one right here. And I can go, well, I have all my values. I'm going to go with the one that I know. I know resistance for sure. And current, I figured out a long time ago. So I'm going to go with current and resistance. So that's P equals I squared R. So let's see here. That's going to be I squared. 2.25 squared, 8. So let's see what that is. 2.25 squared times 8, 40.5 watts. Whew, there you go. It's one complicated circuit. We found out everything there was to know about it. There you go.